Now then we can move into the results. And for the results, we can, of course, describe, first of all, who the participants were. So how many people answered our survey, what were the subjects of this experiment. The number who participated, and you may include those who did not finish the experiment. So the incomplete numbers, which in social science can be quite large, but in applied science areas actually is often quite small. The total number of participants, so we really need to get an idea of the sample frame. That is, where did you do this, how did you do it, and who did you do it with or to. If you had multiple sample groups, if you had multiple conditions, you need to explain those carefully. Control group, non-control group, control group number 2, number 1, etc., and exactly what do they mean. Then you need to summarize the data, the numbers that came out, and the analysis. So even if you're doing a paper like a meta-analysis or a literature analysis, you still have data that gets summarized. That's, in a way, the whole point of our research, is to take big ideas and make them small. So here you need to make it small. Tell me exactly what happened in the data. Include all the relevant results, including things like the exact value for F-test or T-test, for example, degrees of freedom, probability levels, direction of the effect. Remember, sometimes when you do your T-test, it comes out negative or positive. You need to explain what does that mean. That's very important. Do not include individual scores or raw data. So don't include everything. You need to include the stuff that's the result of the analysis. So when you do an SPSS program and you've put in all your numbers and these big tables come out with all of this stuff, you need to really find out where the summaries are, not include all of that, and certainly not include the raw data, which is one mistake novice researchers often make in social science, and that is they take the raw data, combine it up into basically an average, and then they make these big tables and try to come to some kind of conclusions on these. And this is a little bit overload because this is pre-analysis. The point of analysis is to bring those big amounts of data down to a very small level so we know exactly what they mean, what's the result, which thus the section is called the results section, right? Assume that your reader has professional knowledge, and that is you don't need to explain every detail. If you're going to, for example, give the result in an ANOVA table, you don't need to explain what an ANOVA table is or how ANOVA works. You don't need to give the formula. Just assume that they know. And of course, for every professional area, people may know different things. Don't go over basic concepts and procedures. So usually in the results, you do not need to explain the methodology. You did that in the methodology. You don't need to go over it all over again. So try to get right to the point of the results. Tables and figures in your results section should include information that adds information to your writing, does not repeat it. So if you put a table or if you put a figure in, you need to really be sure that this table or this figure adds information. It doesn't just repeat something. So if you can say variable A is 10% bigger than variable B, you don't need a table for that. You don't need a chart. You can already say that in your writing very clearly. But if you have something that's more complicated, like a four-way relationship and an interaction effect, you may need to have a table or a figure to help make that very clear. Only use when words in the, whoops, I skipped that piece. Well, it says only use when words in the body are not sufficient, not enough to really make things clear. Okay, so that was the results section. To be quite honest, the results section in papers can be very disappointing in that you can have this big introduction. You can have this methodology that could be quite complicated and have lots of parts and pieces to it. And then your results are so tiny. That is very normal because the results is everything filtered down. And remember, in your introduction, if you included a hypothesis or two hypotheses or three, those are directly testable in your method. That's what you have the method for. And you have a result. Those results come out and you just state very quickly. A was bigger than B, this is the t-test, this is the standard deviation, this is the reliability, and you just write these things out. And they'd be very short. So don't be surprised if your results section seems awfully short compared to the rest. And you don't need to add a lot to make it bigger. Now, it's always possible that you could add raw information, the data you collected, into your thesis, for example, but not here. Put it into the back in an appendix, an extra section. So if I want to see your raw data, your detailed numbers, not just the results, I can look in the back, Appendix A or Appendix B, for example. Now we get to the end of the paper or the thesis, which is the discussion section. So in the discussion section, we're going to examine, interpret, qualify the results, and draw inferences and conclusions. So we're really going to go a step further now. We're going to tell the reader, what do these results mean? You're going to emphasize theoretical or practical consequences. How does this influence theory, and how does this influence practice? And this is important in hard science and in the humanities. In both cases, you cannot just state that A is bigger than B, thank you very much, game over, that's all. No, you really need to come out and say, A is bigger than B, and that is important because, why? Tell me, why is that important? This is a key idea of the discussion. When the discussion is relatively brief and straightforward, then it may just be called results and discussion. That is to say, it's short, so we just results and discussion. That's one section. Open the discussion section with a clear statement of the support or non-support of the original hypothesis. So usually when you begin the discussion section, you will say, hypothesis 1 is rejected, or hypothesis 1 is accepted. So you make it very clear right from the beginning what happened. You may even repeat the hypothesis. So for example, hypothesis 1, and then quote parentheses, and then you say hypothesis 1, A will be bigger than B under the situation of. And then you explain that this was found to be true, or this was rejected. So that's a good way to begin your discussion, making the reader remember exactly what the hypothesis was. Contribute to your interpretation. The reader's understanding of the problem is your goal. You want to help them interpret, what does this all mean? I think we get the point, right? When you write your discussion, you should remember sources of potential bias. That is, you can point out that your research may not be perfect. It may have some limitations. You can point those out. You also want to remember the measurements. What's the standard deviation? What's the error bars on there? So you can bring this up also. You also want to remember the number of tests or overlap among tests. So if you had more than one test condition or two test conditions, you need to explain clearly here. What do they mean together or apart? How do I interpret this? Effect size is an important idea that we often talk about, but not a lot of people really follow up on because it's a little bit troublesome. But effect size is a statistic that can measure. This may be statistically significantly different, but exactly how different. And that's called effect size. When you have time, you can look that up. But effect size is very important to include in your discussion. Limitations, weaknesses. What were some things you could do better? What were some things that could have caused a problem in your discussion? That's something you can cover. Acknowledge the limitations of your research and alternatives. What are some other ways you could have done this research? Or in the future, maybe other researchers would like to do this research. What are some things they should be careful of? And you should discuss how generalizable, this is a hard word for me to say, generalizability of your research. That is, can your research results be generalized to the public? Maybe you tested 50 people for a drug. Then can this result be generalized to the public? Can it be generalized to people of this age group? Can this also be generalized to just the males or the females in the general population? So your results is this small result. But what does this mean for people outside of your test group? That's this idea of generalizability. End with a commentary and the importance of your findings, which is really pointing towards the future. That is to say, how important are these findings? What do they mean? And how can people in the future build on them or make them better? What is the significance of those outcomes? What problems are still remaining to be solved or answered? Speculation is in order here. That is, you can speculate. What is it that I can do or someone else can do in the future? What's possible? And maybe, what does this mean? This can be especially useful if you have the case where your hypothesis has been rejected. If your hypothesis is rejected, then here is your chance to explain why do you think that the hypothesis you came up with that was based on existing literature is wrong, or is the hypothesis may be right, but your research method has a problem, something is wrong. So that's speculation. This is your chance to speculate. You need to be logical and empirical, of course, and try to relate to theory as much as possible. You need to be concise. Don't go writing on and on and on. Just a few sentences for each point is enough. You don't want to spend too much time on this. Okay, so review or meta-analysis research is a little bit more special. And in a review or meta-analysis research, you need to, in the discussion, define and clarify the problem clearly, because remember, you're not doing a test, but rather you are analyzing the existing analysis. You are collecting the data of other people's data. So it's a little bit of a special case. You need to find out what those relationships are, and then here in the discussion, you need to discuss what are those relationships, and then give steps for the future in this meta-analysis trend. If you're doing multiple experiments, let's say that you have experiment A, and then experiment B, and then experiment C. How can you organize these in your discussion? Well, for each of these, you can have their own discussion. So you can have a little discussion for A, and then a discussion for B, and then a discussion for C. Or if these discussions can be combined because these experiments actually, the results all fit together, then you can go ahead and combine them. Either way is acceptable, and I've done both ways. Combine them when they're really related, but sometimes experiment A and experiment B are very different situations, and so in my discussion, I first discuss A, and then I discuss B. But then after discussing A and B, now I need to have a little bit that brings them together, overall discussion. So we may call that experiment 1, we may call that experiment 2, experiment 3, and so on. Okay, so that's the beginning of our detailed look at MLA and APA. Today we looked mostly at the organization of your thesis, of your research paper. And if you feel that is too much information, Professor Warden, my head is exploding, I can't take it, then you should be ready for your head to explode more, because as we move on, the details of references and the details of writing each of the sentences is going to become even more tedious and complicated, but very applied and useful. It's things that you can really use in your research. Thank you.